So very first day I told you maths is a language. It's a language. Okay. Then digits we call alphabet. Digits we call alphabet. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are digits, no? So that is alphabet. So today I'm going to tell maths is a world. That is a world. Okay. Maths is a world. So in that world we have many different machines. So in real world also we have different machines, no? We have different machines. Car, sometimes any other machine, train, or likewise we have many different machines. So they do some operations, no? They do some operations. Then that machine has specific tasks to do. But some machine has multitasking machines, no? Some machines are multitasking, some machines are specific tasks related. So in mathematics, it is a world. In that world, there are machines. We call their functions. We call their functions. So in that world, that contain function, that is about some functionality. That is about some functionality, no? Okay, now you see, just to think, here, a machine. So we have inputs. So we have outputs. So these outputs are correspond with inputs, no? Those outputs are correspond with inputs. Then all inputs, they do some operation and they that finally give output. So all inputs, they connect and they process and that give output. Then this is we call a function. Function. So you consider we have some inputs. Let's say inputs. In mathematics, we put some numbers here. Sometimes that can be real numbers, that can be imaginary numbers, that can be complex numbers. Likewise, there are different type inputs. So here we have input pool. We have input pool. We call it is a set. Input pool is a set. Especially we define this one by domain. Domain. So each function has their corresponding domain. No? Each function has their corresponding domain. Later we will discuss what is domain and how to identify domain, what is implied domain and so on. Okay, but anyway you identify input set we call domain. Input set we call domain. Okay, then with this functionality that give output, no? That give output. Then this is we call range. Range, we call that is range. So anyway, here this process we call function. In mathematics, we denote this one by functional notations and some properties of the functions. Okay, here domain, it has some elements, no? Then that element set, we usually say capital X, and here this range, there are some outputs. Then those elements we define, we say that set we call Y, set Y. Here domain X, so in this domain, we have variables, we call simple X, so that variable inside capital X, here simple Y variable, that inside capital Y, capital Y. This is general idea of a function. But anyway, you identify function mean a process that has specific tasks, so it has input, it has outputs, okay? Then we gonna analyze about functions. We gonna analyze about function, that is a function. Okay, now here, X we call independent variable. Independent variable. So why we call dependent variable? Dependent variable. Because Y connect with X, no? When I give input, then only that give output, no? When I give input, then only that give output. Then here, this connection we define by a function. So it has specific rule. That function has specific rule. So you should usually think about expression like Y equal X plus 1. Here now onwards you identify this is a function. So here input values, we can put values for X and we can get results from Y, no? So here input values, here output values, result values. Then here input value, here output value. Then Y equal X squared, you identify this is a function. Then Y equal sin X, you identify this is a function. Likewise, we have inputs and further we have outputs. Those outputs are corresponds with inputs. No? Those outputs are corresponds with inputs. Okay, now anyway, here all these are we call functions. Further we have functions. Here all are functions. Functions. Okay, now here function, let's say f. Function, let's say f. So here fx, that represent f of x. We say f of x. So that result will be y value. No? Then y equal fx. This is one of our notation. Okay, f of x. You don't think this is f times x. This is not f times x, okay? This notation represents y is a function of x. Y is a function of x. Here y is a function of x. So fx we say f of x. F of x. Or function of x. Function of x. F of x or function of x. So those are general idea. Now you identify, we have variable inside here and we have variable outside here. Then here input variable, here output variable. Then this is called independent variable and this is called dependent variable. Dependent variable. Okay? And you think about some function like, you consider a cylinder. This is a cylinder. So let's say here radius, let's say here height. Then we know this volume. We denote by pi r squared h, no? This is also a function. But the thing is, here r, h, both are variables. Both are variables. Radius, as radius varies, volume varies. As height varies, volume varies. Then here this function has two variables. We call multivariable function. Here y equal fx, then here we can denote this one v, r comma h. Here multivariable, special two variable function. Then volume depends with radius and height. Volume depends with radius and height. No? Likewise, in nature also we have different connection between two variables. Okay, boiling point decrease, boiling point decrease with height, with altitude, no? Boiling point decrease. Likewise, there are many different connections, Then to analyze real world, we need functions. To analyze real world also, we need functions. So now we are in artificial world, digital world, and mathematical world. We are in there. Then all those worlds basically runs with multi-billion functions. Multi-billion functions. Okay, when we discuss about our world, so all the things has made by multi-billion functions, multi-billion function, many functions. Still they are finding functions. To describe this real world, we need to identify different functions, different functionalities. Okay. Likewise, here we call two variable functions. Two variables. Okay, two variable functions. Here single variable function. This one single variable function. single variable function. Single variable function. Then the main thing you identify, function mean a process that has connection between input and output, that has specific connection. Then one function can do one single thing. One function can do one single thing. Then each and every input has their result, no? Each and every input has their result. Okay. Then here this function accept only inputs that related with that function, no? That related with that function. Then the corresponding result will be specific one, unique one. Okay. Then every input has one output. Every input has one output. That's the thing. So that is function. Okay. Anyway, you put this sketch first. Put this sketch first.